Hey guys, welcome back to our channel. Today we are going to solve a very interesting problem, that is for sum. Okay, so in the problem statement, what we have is we are given an array, right? And we have to find four unique, not four, basically unique quadruplets. And our quadruplet means a pair of four. Okay, so we have to find such pairs containing four elements such that it is equal to the given target. Okay, so let's say we have this array 1 0 minus 1 0 minus 2. So we have to find a pair of four elements such that we are having a target 0. So let's say this minus 2 minus 1 1 2 will make the sum 0. This also will make the sum 0, right? And so on. And the only condition we have to take care is that we should not use the same index element again. Like minus 2 is here, so we can't use minus 2 again in a quadruplet, right? And also, this quadruplet elements should appear unique. We should not have this minus 2, minus 1, 1, 2 again in other quadruplet, maybe in a different order, right? So these two conditions we have to keep in mind while generating the quadruplets. They have to be unique and we should not use the same index element again, right? So before we start coding, let's think of the possible approaches how we can solve this problem now. So we are given this array 1 0 minus 1 0 and minus 2. Okay, and now what we have to do is we need to find the unique quadruplets such that each pair of quadruplet do not contain the same index elements again, right? Now let's start from the very brute force or the basic approach, and in this problem what we need to do is we need to find the quadratic sum such that it is equal to 0. Okay, let me write the target here also, which I missed, such that the sum is equal to 0. Okay, that we are looking. Now let's start. Basic solution can be generate all quadruplets, and whichever sum has a whichever sum equals to this 0, and that we can store and return, right? And how to generate all the quadruplets, that we already know from the previous lecture, that we can loop for each of the quadruplet pair, and you know and then generating the sum, right? So keeping it very straightforward, what we need to do is, let's say we are starting from, you know, and I am assuming that n is my length of the array, right? And here, see, we are using for loops for each element. Now, for the first element of the quadruplet, we are assuming it is at position I, and as it has to be unique, so I'm initializing the second one by I plus 1, and same j plus plus, right? And in this also, the next one can be initialized with j plus 1, and same again the same approach, right? Now the next one, let's say we are using a variable L, and it can also be initialized with you know k plus 1 and then simply L plus plus, right? So we know that these four pointer or the looping variables, we can then use the sum, right? And we can simply sum what we have in a of I, a of j plus a of k plus a of l, right? If this sum is equal to 0, right, that means we got the quadruplet, right? This is the very basic approach that we can do. Now, only problem is in this, we are generating all the quadruplets, and we know important condition is that they have to be unique, right? the quadruplets have to be unique, and this is not unique because we are generating all the pairs, right? Now let's think how we can make them unique, right? Whenever it comes to uniqueness, and whenever we are storing unique elements, the most obvious thing which comes to our mind is set, correct? One is the set, and we know that set can have unique elements, right? But here the order also matters, right? We know that order can be different, right? So we have to make sure that order also remains the same when we are inserting in this set, right? So to make sure that order is also the same, before inserting we can sort the quadruplet. So that, let's say, what I mean by sorting is, let's say I'm taking any random variable, let's say one quadruplet I'm getting is this, okay, another one I'm getting as this. In the end, these two are same, okay, because we are using same for elements. This is also same. So if I sort both of them before inserting, what will happen? Like if I sort this, what will happen? I will get 0 or maybe -1 first, then 1 and 2. Same, after sorting I will get this. And if I try to insert into my set, what will happen? The set will always have the unique elements, right? So similarly, what we need to do is we need to sort our quadruple, then insert into set. Okay, these two operations we have to do, and this will be the most basic approach that we can consider. Looping through our array, generating all the quadruplets, and to make sure if they are unique, we need to follow two things: just sort it, and for uniqueness use set. Basic, right? No fancy stuff, nothing. Now, talking about the space and time complexity, it will be, we are using for loops, right? And it all are running till the end. So obviously it will be n of n to the power 4, right? And space complexity, we know we are using a set, right, for uniqueness. And let's say we are using of n, not of n, one second, yes, so we are using set to store our quadruplets. So it will be depending upon the number of quadruplets. Okay. So you have to tell to your interviewer that this space complexity is not, always the same. It will depend upon the number of quadruplets because only that much space we will use in a set, right? So till here we have done the basic approach. Now let's see how we can optimize this, because see, whatever we say, this n to the power 4 is way too large. Okay, now let's think of some optimizations. So we have seen the brute force approach, right? And the problem was, for sure, that the time complexity was of n to the power 4, right? Now let's think how we can optimize it, right? As we saw that we are looking for the quadruplets, each when it sums up we are getting a 0, that is our target, right? And we did 4 for loops, one for each element, right, to get one for each element. Now we can try to omit the for loop for the fourth one. Let's see how we can do. We are using the same approach. Okay, so let's say I can write this, right? If I know this is equal to 0, my target, I know this a of L can be a of I plus a of j plus a of k, right? I know a of L, I can find it here, right? Like this way also, like instead of looping and checking each future element, I know I can get it from my earlier elements summation, right? And if I'm looking for the earlier elements, right, that means I am looking for the hashing, right? Because I want to remember what I have seen in the past, right? Only then I can get to know what are the I, J, and K, right? So we can use hashing, that we know. So now let's see one more thing. How we make sure that we are not using the same index elements again, right? Because let's say if our one pointer is at this, one is at this, one is at this, one is at this, we don't, let's say, we are not sure like which element we can consider, right? Because how we will identify that we are not using the same element again, right? So to solve this problem, okay, what we can do is, as we have done in our previous video, please do check it out in the 3-sum video also. It is just the extended version of it. Okay, what we can do is, before we start, this we know, or wait, this we know is our idea. Okay, let's move it here a bit, and we can reduce the size of this. Yes, so keep this in mind and let's start. So what we can do here is, we can assume I and j to start from first and second place, and make sure that k is here, right? Okay, and we move k in forward direction. Okay, so let's say if k reaches here, right, and ij are in the beginning, so what we need to look for L is in between I, j and k. If we look in the middle of I, j and k, it can never be the case that we'll get a same index element again, because we are totally ignoring the I, j and k, and we are just searching the middle part where no pointer is there, right? So this approach we can use, right? Now let's see how we can proceed by a dry run. Okay, let's say I know we will need a hash table. So let's say I do this, and initially I have my first two pointers I and j here, right? And let's say k is here, right? So we know that a of L will be in this minus of 1 plus 0 plus minus 1, right? Which is equal to 1 minus 1, 0, and it is 0, right? So what does it mean? Does 0 exist in our hash table? No. So that means we haven't got our 0 yet. So what we will do? We will move our k pointer. Now k is here. Okay. And before moving, we just have to store this minus 1 in the hash table so that we can recognize, right? Now for next iteration, a of L can be 1 plus 0 plus 0, which is minus 1. Do we got minus 1 in a hash table? Yes, we do, right? So that means we got our quadruplet, right? And we can store this quadruplet here, right? Now, one we got, now we will push this 0 in the hash table and move our k pointer further. Okay, now a of L will be minus of 1 plus 0 minus 2, and it is plus 1, right? Plus 1 exists? No. That means we can store this minus 2 in our hash table, and we can move our k pointer ahead, right? So a of L will be minus of 1 plus 0 plus 2, which is minus 3. Does minus 3 exist? No. That means we can move our k pointer, and we can simply insert this 2 here, right? Now the first iteration is done and we got our first quadruplet. Now keep this in mind, when one iteration is done, the steps we need to do before going to the next one. Okay, now this is done. Now what we will do is, for the next iteration, we will move our j pointer. Okay, now j will come here and we will initialize k from here. Okay, and now we are starting a new iteration. That means we need to empty our hash table, right? Because now we are looking for a new one. Okay. So same way we got our ij and k and we will continue this hashing process. Okay. So this is the process that we will do. Okay. Here also what we need to do is we need to we need to store it in a set for uniqueness, right? Okay. And for that the time complexity that we will get here is of nq, that is the time, and as we are using a hash table, so it will be space will be of n plus number of quadruplets that we got. Okay, so that will be the space. Now obviously we have reduced the time complexity, but what we have done, just see, we are using O of n, like we have increased the space, right? It is not equal to O of n, but we are, adding an extra space for quadruplets also. See, this we can't manage as of now, but this hashing, right? Can we see a better way or a better idea to do this? Let's think how we can optimize this further. We have seen one more approach using hashing, right? Now let's think how we can, optimize it further. Is there any other alternative solution or better than hashing, right? Now just, see why we need hashing, or, or how we can, optimize the extra space, right? So just think, okay, from the beginning, what problem we had? Okay, let's, identify our problems. The constraints that this I is not equal to j, is not equal to k, is not equal to l, right? That is the first constraint. That means all indexes should be unique, right? And each quadruplet that we get, okay, has to be unique, right? These are the two things, right? And to achieve these two things, we know that for uniqueness, what we did was set, and so we did set and the sorting, right? These two we these two things we did, and because of this set, we used extra space, right? That's how we did till now. Now, how we can omit this usage of set, right? Because this is the extra space that we are, using, right? So, if we see in the set, the problem was we are not getting the unique elements, right? And why was the problem? I also earlier also I have showed you. Let's say my, you know, one quadruplet is 1 minus 1 0, correct? And the other quadruplet is 0 0 1 and minus 1, right? These two possible combinations are there. Although they both are same, they have 1 0 minus 1 0, here also the same numbers, right? And for that we did sorting and then store, right? And this happened because there can be, no exact sequence how we are generating, right? Because see, obviously, let's say we have three integers. If we start from beginning, then always there will be a case, right? One will come first, then two, then three, right? It can never be like three is coming, right? So that means if we sort the array, then we will always get the unique quadruplet. We can't have these two orders, right? Correct? So let's, use this intuition and let's see, okay, how we can proceed, right? Let's see how we can proceed with this. Okay. So before we proceed, what we can do is just keep this, aside, that, okay, this is one thing. Now, let's assume we sort this array. Okay, first let's sort the array. So what we will get after sorting? -1, 0, again 1, 0, then 1, and then 2, and I forgot this -2 will also come first, right? This is after sorting, right? Now we know if we generate sequentially, we'll always have the unique ones, right? Now let's start. How we can do? Same. Assume I is here. You know the two pointers approach. J is here, and assume K is here initially, and take my L as the last one. Okay. For now, in the two pointers we have, by the name we must have two pointers. Now we have four. So assume these first two are the constants, like we are not even touching it for now. Okay, just consider this K and L. Okay, right? So what we have to do is take the sum. Okay, let's sum this up. I, J, K and L. What we will get? -2, -1, plus 0, plus 2, right? And it will be 2 minus 2, cancel out, 1 minus 1, right? So current sum is -1, right? And we are looking for a sum 0, correct? And -1 is less than 0. That means we need to increase the sum, right? And if we need to increase the sum, I, J we are not touching. What we can do? K between K and L. If I increase K, the sum will increase because they are sorted. And if I decrease L, the sum will reduce, right? As they are sorted. So what we can do? I will move my K pointer, right? Now, as we are moving, now comes the second condition. We don't want duplicates, right? We don't want duplicates to be generated. So what we can do is, if after moving to the next, if the value of a of k remains same, that means we can move one more step. So our k will become here, right? Now let's sum this up. -2, -1, +1, +2. What we will get? This cancel out, this also cancel out. We get the 0. That means we got our quadruplet. So we can just store this. Okay. Now see, as we have sorted, we are only getting a unique one and in the order, right? That's the beauty of initially sorting and using the two pointers. We got our quadruplet, right? Now, as we got our quadruplet, we can increase both, K and L, right? Correct? Now L will become here, we can reduce L, and K if we increase, it will come here. Now and we have to, run this loop till K was less than L, right? Because if they both, crosses each other, that means we are done. Now they have crossed each other, that means we are done with the iteration, the first one, right? Now, the first iteration is done, correct? Now, what we can do? For this ij, this iteration is done, right? Now what we can do is we can move our j pointer. Let's move this j here, right? And k should be the next one, and the l can be the last one, right? Now again, same iteration. -2, +0, +0, +2, right? If we sum this up, we are getting 0. We are looking for 0 also, and that means we got our quadruplet. That means -2, 0, 0, 2, right? What we can do is we can increase our k and l. If I increase k and l, and maybe decreasing the l, so what will happen? They both will point to the same position, right? And we can stop our iteration, right? So now what we can do is moving our j. In case of j also, if we move by 1 and if they are same, that means we are done with this 0. That means we can move our j one more, right? If I move j here, then the k will be here and l will also be here, right? this also not possible, right? So that means we are done with this iteration, right? Now J, K and L all we have covered. Now what we need to do is move our I, right? Let's say this I which is here, J will all with the here and K here and L here, right? Now run this iteration. -1 plus 0 plus 0 plus 2, which is 1. Now 1 is greater than 0. That means we need to decrease the sum. And if we need to decrease the sum, it means what we need to do? We need to decrease our L pointer, right? Because the array is sorted, and if we make reduce L by 1, then overall sum will reduce. That means now check the sum. -1 plus 0 plus 0 plus 1, right? And it will be 0. That means we got our quadruplet, right? -1 0 0 1, right? Now what we can do? We can increase K and L, and then the K and L will cross each other, right? That means this condition will become false. That means we have to start the new iteration, right? So I think now you have understood the gist of this approach. What we have to do. Only make sure that if we are moving our pointers, we should not reach the same element again, right? And by same element, what I meant is, let's say if my j is here, after moving one, j can't be 0 again, right? Because otherwise there will be a chance that we are getting duplicates. Okay. So from beginning, we are talking about this. Why we need set? For the uniqueness. And what we did? Sorting. That is the reason for the extra space. Now in this approach, we have removed the extra space. So the time complexity will become O of n cube. Okay. Why of O and Q? Because I and J we are looping for the constant, and then K and L we are moving. So moving K and L will be N, and I and J will be take two more loops, N square. So total will be N cube. And space, we are not using any set, only the quadruplets, that is our answer we are storing, so that we can return. Okay. So now this is the all the approaches that we can think of. So now let's go back to our code editor and let's start coding. Now we have understood all the approaches that are we can think of and are possible for this problem statement, right? Now let's start coding. Okay, what we have thought. So what we are given is we are given a nums array, we are given a target, and we have to return the quadruplets array, right? Basically the array of array, right? So what we have so from beginning, let's initialize our answer that we will return, and we know that we have to return this array, right? So simply return this, right? Now what we can do is sort the array, right? So that we get unique quadruplets, right? Quadruplets. I am hoping that the spelling is correct. Okay. That means to sort the array, we know that we have a sort function, and as it is an integer, not a string, so we have to do some manual. We have to pass a callback function, and we have to sort in ascending order, so we can return a minus b. Okay. Now the array is sorted, so we can use our two pointers approach. Let's start looping. We know that we can assume our I, the first two variables or the looping variables, to be constant, that is I and j, and we know that j can start from the I, so this we can do, right? So basically we are treating I and j and constant. The next two k and l we can consider for the two pointers. Okay. Now initializing the third pointer, that is k, we know it will be the next of the j, and the L1 L pointer can be the initialized to the last index, right? That is nums.length minus 1. Now, starting at 2 pointer, we know that we have to do this process until and unless their 2 pointers crosses each other, right? Now, let's see what is the sum we are getting. Okay, that is nums of I, nums of j, and nums of k, nums of l, right? So, what are the possible cases, right? The sum can be equal to our target that we are looking for, or the sum can be my less than the target, or the sum can be greater than target, that is we can put in the else condition, right? These are the three possible cases, right? Now let's see what will happen if my sum is less than the target. That means we need to increase the sum, and if we want to increase the sum, simply increase the k pointer. And here the sum is greater than target, that means we need to decrease the sum, right? Simple till now. Now we know that we have seen that there can be, duplicates in the array, like 0 0, 2 times 0 we have, right? So after increasing k or anything like increasing or decreasing the pointers, make sure that the next one is also is not same as the previous one. Like it can't be, we are at 0 and after moving to the next we are again at 0, right? So to make sure that we are not at the same, what we can do is we can put check, and the check can be if nums of k is equal to my previous k, that is k minus 1, I still will increase my k, right? I want a unique one, right? Similarly, for the L also, what we can do is if my nums of L, right, is equal to the L plus 1, right? Because we are starting from the last, so here we are taking L plus 1 and reduce it, right? Now, when the sum is equal to target, that means we got our quadruplet, that means we can push into our array the four elements, that is nums of I, nums of j, nums of k, nums of l, right? We know we got our quadruplet, and as we got our quadruplet, that means we can move our k pointer by 1 and l pointer by reducing by 1, right? Again, the same condition here also can exist, that if we are at 0, we don't want to move to again to the 0, right? So again, the same condition is applicable here also, that is if we will check if our k is equal to the previous k, that is k minus 1, we still will increase the pointer. And similarly here also, see, we are doing k less than l because we don't want to, cross the 2 pointers and maybe go beyond, that is k should not go beyond the length of the array, right? Because the l we are initializing from the last element, so if we increasing k, we have to, terminate this while loops. So we are putting this condition that k should be less than l, that is we are not crossing the 2 pointers. Okay, here same condition here, that we can give l plus 1 and we can reduce our l, right? Now for k and l, in all the three cases we are done. Only thing we forgot here is, what if increasing the j also giving us the same element, like j is at 0 and for the next iteration j again comes at 0. Same for the case of I, right? So to solve this, what we can do is, we don't want to do it in the first iteration. That means if I is 0, we don't want to do. So we will do if I is greater than 0, right? And we are getting the same I as the earlier one, right? That means we don't need to do anything after that. We can continue and move to the next iteration. Similarly for j also, for the first time we are good. That means if j is equal to I plus 1, but if j is greater than I plus 1 and j is equal to my previous j, that is j minus 1, that means I don't want to run it, right? Here, that is the basic thing. Okay, I know many people will consider that here in this, if it is equal, right? I'm not doing anything with j and I, but here if it is equal, I am changing my pointer. So just for, if you are a beginner, just see that I am having a for loop for this, right? So for loop, I am getting this j plus plus and I plus plus here. But here, as it is a while loop, I don't have this k plus plus. I have to manually do it, okay? So that's why. Now we have considered everything. Now let's run this and see. And it is running. So both the test cases have been accepted. Now let's submit this solution and see if we have done any mistake or something needs to be done. So it is accepted successfully. So hopefully you guys have understood the approaches and the solution. And if you have any doubts, please feel free to mention in the comments. I will help you out. And if you have understood the solution, just mention understood. So that's it for this video. We'll see you in the next one. Till then, bye bye. Take care.